Hello, everyone. My name is Taryn Blake, and I am the Community Engagement Program Manager for our Siemens software community. I'll be your host for this enablement session, and we are here today for our Technomatics virtual user group to discuss model and program gantry robots. And welcome to everyone who is here. As most of you know, our presenter for today is Mr. Steffen Bangsow. He is a freelance simulation expert and has been in this space for many years. He's completed hundreds of projects and training sessions, almost 50 for us here in Siemens software. And Steffen has published 5 books on plant simulation. He has a 6th book coming out very soon, and he's definitely one of our leading contributors to the Siemens PLM community. So for the tutorial today, he is going to walk through a few big steps. So inserting the gantry robots into your simulation model, configuring and programming the robot behavior, using I-type and H-type gantry robot configurations, and then applying the robots in real-world transport use cases. So as always, we are here live. After the presentation, Steffen will go through all the questions. You can also come off mute after the presentation and just ask your question using the hand raise button that is in the menu on the top of your screen. That is all for my introduction. So Steffen, feel free to steal the screen.
Hello. Today's topic is gantry robots, and for this webinar, it's the gantry robot from the Cranes and More library from Plant Simulation. I will offer another webinar how to create a gantry robot, for instance, from a step file. So first, if we want to use the gantry robot, we need to add the Cranes and More library to our class library. And so we start at home, manage class library, and you find the Cranes and More library here under standard libraries. It's free, but Siemens made a lot of changes in this library, and you need to be carefully which version you use. I use version 2504, and if you have an older version of Plant Simulation, for instance 16 or before, then the gantry robot may work a little bit different. And so our today's webinar, it should work working for 2302 and 2404 in the same way. Before you need to check. Okay, you find the gantry loader here in this library, and you also find the gantry loader documentation here, because at least for me, the standard help of Plant Simulation doesn't work for the gantry robot. And so you have here one additional documentation, and you find here all the description of the attributes and methods of the loader. And many of the methods we need today. So if you want to look for help, then you need to use here this documentation when you don't find the right help in the internet. So first, I want to create a very simple example. I take the gantry loader from the class library, and normally we need to adjust some things here. Double click opens a configuration menu. We need to change the length, maybe 15 meters, and we need to change the height, maybe 4. You can have more than one loader on one track here. The gantry loader is based on track and transporter. The loader itself has a certain length and a speed. You can also switch on the acceleration. And we need to configure the gripper. We need to configure the gripper length, maybe also 4 meters, gripper height 4 meters. And again, the speed for the z-axis you can set here with acceleration, and you can activate a double gripper, but you need to check in reality if this is possible. Normally, you have two different kinds of gantry. You have a loader and eye loader. You have only one bar with a gripper, and the H loader has 2 bars and grippers, and so you have a double gripper, but they have 2 different transporter objects here in plant simulation. Okay, that's it. All the configuration you have to do here in this menu. And if you start the simulation, you see, okay, this is now the gantry robot. If you open here this gantry loader, double click, and you see on the head of this menu, you have a little symbol on the left side, and you see, okay, this is a transporter. And this is the transporter configuration menu. The gantry hook here, it's not a separated object. It's only an animation on this transporter. And so it's the same. It's, oh, the gantry hook, it's still a transporter. Okay, then it's also a transporter. Okay, this is the basic objects the gantry loader consists. And now I want to make a first very simple use case. I have a source. Underneath the gantry robot, I have a station, and I have a train. And it's better to use the planning view to adjust all this stuff. And now the gantry, this gantry robot should load one part from the source, move it into the machine. After the machine finished the job, then the gantry robot should unload the machine and place the part into the train, and then the cycle should start from beginning. And so I need a method. And I use one init method to call this method for the first time. Gantry program execute the call chain. I want to call other methods here in the init method, and so each program needs to run in its own call chain. Otherwise, it would stop here until the first gantry program has finished. And okay, there are 2 different kind of methods for the loader here. The first one is there's like a comfort method to transfer 1 MU from one station to another, and the gantry robot makes all the movements it needs by its own. And one of these comfort methods is transfer MU. And if you call transfer MU and says, okay, this MU you want to transfer, you need to specify the destination, and then the loader goes to the right position on its track, and then lower the hook, load the part on the hook, lift the hook, and then goes to the destination, lower the hook, unload the hook, and lift the gripper again. And then this cycle stops. And so it's quite easy. I need one link to the loader here. And there's an attribute loader one, and with loader one you get access to the first loader. And here I start loader. It's an object, and this is gantry loader. Loader one. The same as if you use the portal crane, then you have the same with the portal one. It's the same pattern here. Okay, I don't have a set interval here for the source, but I don't know the order of calls here. The init will be called quite early, and then it calls gantry program, and so it's not sure if the source already produced the first part. It's all at the time 0 here in the simulation, and so it's better to wait for the part. Otherwise, you get a problem if you call source.cont. And then I just call transfer mu. The first parameter is the mu you want to move, and the second parameter is the destination, the station. And this we can already check. Okay. And all is done with only one command, and this is transfer mu. All the movements are encapsulated into this method. And then this is a little tricky here in this method. There are some methods, they need a certain state of the loader, and the state is idle. And we can have a look here in this method, transfer mu. I place a breakpoint here, and then we have a look into the library method. And this is a problem here. This method waits for the loader state idle. And so we need to set this state if we want to call this method a second time or again and again. And so we need to place one method here, and this is end sequence. And this sets . the state idle to true, and now I check the help. I press F1 and nothing works. The direct help doesn't work here for this library, and so you need to check out the documentation. Or you believe in me, you need n sequence sets the state idle to true, and so we need to call n sequence, then idle is true, and then we can call transfer mu for the second step. Second step is we need to wait until the processing on the station is over, and then we need to transfer the part from the station to the train. And so we need only 2 more lines. First is wait until, station with rest working. We can check if the processing is finished. And then we need this 2 again. Transfer mu, now it's station.cont. And destination is train. And then we need to end the sequence for the next round. And now it should work already. So fine. And then we needed to start the second round here. We need to recall this method gantry program to come to an end loop, to endless execution of this program, and this we can make with self.execute new call chain again. Okay, and this is I guess the shortest program you need to control a gantry loader. Here I type a gantry loader. Execute new call chain. And it starts again. Okay, for the H-type gantry robots, they are another set of methods. And so we need a second use case. I could take a second gantry loader, make it again 15 meters long, 4 meters high. And the cribber should have 4 meters high and 4 meters length. Okay, and we need to set another length for the cribber. Now we have 2 cribbers, and our part is 0.4 meters. And so we need a little distance here, for instance, 0.6 meters. And then we have, it should be H-type loader. So we have 2 of these, and both are transporters, and the first transporter is a tractor, and so they are changed together. Okay, and as a second example, I want to have one source and 3 machines. And 1 train. Okay. This machine added 3D properties should be processing. The second one should be cleaning. And the third one is testing. The first one has 60 seconds. Oh. Cleaning. Maybe you have a processing with oil or other liquids, and then the part is dropping, and you go inside a cleaning box, and there you have pressured air and cleaning the part before you test it. And so it's here you need to exchange the parts. Here you would go in, place it, and take it out after maybe 5 seconds. And here you need to change the parts again. And this is also 60 seconds. And so our the process of the gantry robot is a little bit more complicated. For simplify the programming, I want to place a part on processing and testing at the start of the simulation. Otherwise, I would need different processes for filling this line, but I don't have time. And so I place parts inside of processing and testing. For statistical, normally we cut some minutes, hours, while the line is filling from the statistics, so it doesn't make any difference if I place parts here. And this really simplifies the programming for. So I place parts. Not in cleaning, because cleaning should be a process in between, and I place only one part here. It's all it should be empty at the start. Okay, and then I need a second method. And again, this method I call the first time using the init method. So init works. I have 2 parts, and then I need to program a cycle, and the cycle is take a part from source and replace the part at processing. Then go to cleaning, place it here, then wait until cleaning is finished, then pick up the part and replace the part in testing, and then go to the train and place the part here in train. And for all these steps, the gantry or the loader has a special method, or Siemens supports methods that encapsulate this type of movement. So first, again, I need a loader, variable, object, and I guess this is gantry loader 2. Yes. And again, loader 1. And then I start with get one part from source. I get a source 2. The first command, pick mu from. Source 2. And then there is a one command, replace mu at, and I only need to specify the location and the location's processing. Okay, let's try this. The method itself waits until processing is finished. You don't need to write anything here. You don't need to write. You don't need to wait for a state change of the loader because the method is running until the task is finished, and so you get a very compact programming here. This has changed during the last versions. And next method is place mu at. Instead of replace, just place mu at. And the next is cleaning. Next step. And then again, it's a little trick. We need to call end sequence. This sets the attribute idle to true because the next method, it's pick mu from, requires also the state idle from the loader. And so we need to set this state in this point. Then we wait until cleaning as walking is false. And then we can pick the part again from the cleaning. And the method is pick mu from. Okay, let's try this. pick the part from the source, replace the part at processing. Then I place the part in cleaning. I wait a little bit. Then I pick the part from cleaning, and then I need to replace the part in testing. And this we have already here. These 2 steps I need again. I replace the parts in testing and place the part at the end at source drain 2. And very important, at the end we need to set end sequence again, because pick MU from, this requires the the state idle from the loader, otherwise it will not start. And so one advice from my side, if it's stuck somewhere, then place a class breakpoint here and have a look into the method of the library. And you can use F11 to go inside. And here you'll find the conditions you need to create to start this method. And it's again here, loader state should be idle. And so you need to call end sequence at the end of the program or in between if you want to use this method. And maybe other methods in the same way. And so you can check this. So it replaces the part in testing, unloads the part into the train. And then we need a restart of the program to start the next cycle. And quite the same like here with save execute new call chain. I call the same method again. And then the loader starts its next cycle. And again, here you can find the documentation. Here you can find all the methods. I used almost all. There are some additional and very easy to use. Okay, and now the gantry is running in a closed loop. Okay. If you want to change, for instance, the appearance of this gantry loader, then you need to change the library, and this you need to do in several steps. And for instance, here you need to edit the library information, and you need to unlock the library. And then you can then you have access on the library elements, like here material flow, And here you can find the gantry loader and the hook. And here you can change the elements in 3D. But if you unlock the library, then you lose the possibility to create update or to install updates easily from plan simulation. And so you need to decide to open the library and change the library if you need another gripper, for instance, or make your own gantry loader, because at the end it's still transporters on a track. Okay, that's it. There will be a second part, and then I take a step file and create the gantry robot from a step file, like the step file you get from a robot producer, and then yes, it's a little bit work for in 3D to create this behavior from a CAD file. And the same as if you need more control on the object, about the object, this is difficult. You have some more methods here in the gantry loader. If you go here and look in the user-defined attributes, you find a lot of methods here, move hook, move loader, move tool, but it's not anymore in the help and in the documentation, but you can use these methods to create some more detailed animation or modeling of this object instead of using this complex and comfortable methods I have shown you. For instance, if you said, okay, this is the wrong gripper, it should take the same gripper to lift the part. Then it doesn't work with this complex methods, and then you need to create your own methods to address the right gripper. Yes, and it's transporter on tracks. You can have more than one loader on the track, and then the loader also may collide, and then you need a collision avoidance here for the gantry loader, and then it may be more become more complex. And also, if you have a lot of machines here and you have a lot of tasks, the programming can really become complex.
Okay, so you should be seeing right now, yes, the Technomatics plant simulation community, a screenshot of it. In the link, you can actually click there. If you haven't bookmarked that link already, you should. The topics for our next two sessions for June 24 will be high bay warehouse modeling basics. You can click through there if you'd like to register for that topic. And Wednesday, July 8th, we're doing create a heat map for tracking traffic analysis. So Steffen will be heading both of those session topics. You can click through to sign up already. And then as stated, the videos for this recording and all of the recordings end up on the URL that's shown on the screen. If you'd like to follow the topic, which is what the animation is showing, click the follow button and choose every post underneath the envelope icon. So that'll make sure that you get a system email every time we add a new video or new registration link or answers to questions on these topics. And then this screen, I always just like to let people know, in case anyone is new, we do have some comprehensive education from the Siemens Accelerator Academy. You can click through the links there. They do offer a plant simulation associate certificate. So if you're new to the space and you just want to see something from A to Z, those are the topics that are available, and you can get more info there. The next one is Realize Live. We've been talking about this for several weeks. We were just in Detroit last week. Steffen, myself, I'm sure some of the members on this call were there. There are still Realize Live events happening this summer in Europe and in APAC, so in India specifically, and Amsterdam in the Netherlands. And then for those of you who are in Europe and near Germany, and maybe you're not able to travel for Realize Live this summer, in the fall, there is going to be a plant simulation Realize Live club for just one day in Munich. And so that is free to attend. You can use the QR code there to register. I'll try to get the URL for the recording, but we can post it in the forums as well. And ultimately, they're thinking it'll be about 300 people, 30 presentations, so customer lectures, technical lectures. You can look at all the details there. Also, they're still open to presenters. So if you have a topic you feel would be applicable to this, then you can use the other QR code, the little one, and volunteer to be a presenter at that event. That is all for me and announcements. This is Steffen's contact for the community. His information for freelance simulation and the link back to the forums if you didn't bookmark that already. Well, applause is a good thing. So glad to know that y'all are here and that you've enjoyed the content. Steffen, I always appreciate you just jumping in to provide this for us.
Okay, then thank you. And until next.
Yeah, see you guys in the forums.
Thank you.
Bye, everyone.
Goodbye.
Bye.
Thank you. Bye-bye.